Hello guys, welcome to DMS AI EduTech. So from this series, I am going to start the entire notes of each and every subjects in B.tech first year, second year, and third year. So in this particular video, I am going to explain you about a subject called design and analysis of algorithm. So in this subject, the first topic is about what is meant by an algorithm. So coming to the definition of algorithm, see, an algorithm is a step-by-step set of instructions designed to or or discovered to perform a specific task or to solve a particular solution is called an algorithm. What is meant by an algorithm? Algorithm in the sense it is a step-by-step instructions or a step-by-step sequential steps which is used to perform a specific task or or to solve a particular problem is called an algorithm. Coming to performance analysis, see, performance analysis includes the process of understanding how efficient an algorithm is working compared with another algorithm. That's mean by comparing with another algorithm, how efficiently it works based upon time, space, or time, space, for example, like, okay. Now coming to this uh, performance analysis, we have two types. See, time complexity and space complexity. This process is mainly used for choosing the most optimal path or optimal algorithm. Now coming to these types, we have time complexity and space complexity, right? Now coming to time complexity, the amount of time that an algorithm is required for its execution, the amount of time which is required for to complete its an algorithm's execution is called time complexity. That means the amount of time taken to complete the execution. In this, we have three types of time complexities. In that, best case, worst case, and average case. See, what is meant by a best case? Here, coming to best case time complexity. See, if an algorithm takes minimum amount of time to complete its execution is called a best case time complexity. That means less time. The algorithm which takes less time to complete its execution is called an best case time complexity algorithm. The algorithm is of best case time complexity. Then coming to worst case, it is similar to best case, but here if an algorithm takes maximum amount of time to complete its execution is called worst case time complexity. That means it take more time. It take more time for execution. Then it is called a worst case time complexity of an algorithm. Now coming to average case time complexity, it is if an algorithm takes average amount of time to complete its execution is called average case time complexity. See, in the heading itself we have that average case. Average case is nothing but the time is required as an average time, which average time is in the sense it is a particular time or it is a correct time. See, coming to this average time, average amount of time in the sense here coming to here best case is nothing but the best case of the best case of the time complexity, and here worst case of the time complexity. And coming to average time, average amount of time, we here we take only average amount of time to or then algorithm, the particular algorithms takes average amount of time to complete its entire execution. See, this is called about average case time complexity of an algorithm. Now coming to examples, see here, for example, take a linear search algorithm or linear search example. Consider 1 second for one each search element. See, coming to a linear search, we have number of elements, right? For example, 1 2 3 4 5. See, in this algorithm or in this array, we need to find an element, and the element we need to find. So here coming to here example, if we need to find element 1 in this array, if we need to find element 1 in this array, see here The best case time complexity is nothing but here it's take only 1 second. That means here for each search each search element, and it's nothing but if we search an element it's take 1 second of time, and if we search two elements it take 2 seconds of time. Then if we find element 1 it takes only 1 second of time. That's mean it is a best case time complexity of an algorithm to find an element. See, now coming to second case, this is case 1, this is case 2, right? Coming to the second case, here we need to find 3. 3 is nothing but 3 is in the third place. That means the algorithm first checks the 1 and then go to the 2 and then go to the 3. For checking this 1 we need 1 second, for 2 we need 2 seconds, and for 3 we need 3 seconds. That means it is an average case time complexity. That's not a worst case, or it is not a best case or a worst case, but it is an average case time complexity to find an element in an array. See, now coming to third case, it is about worst case time complexity. To find the worst case of time complexity, see here the array, this is an array, right? So in this we need to find element 5. So here for searching an element, first element it takes 1 second, for second element 2, third element 3, and fourth element 4, and fifth element it takes 5 seconds of time. That means it is a worst case of time complexity to find an element in an array. The maximum amount of time to search an element. So this is all about types of time complexities. See, usually we use two methods, two approaches to calculate the time complexity. In that, the first one is frequency count, and second one is asymptotic notations. See, we see this asymptotic notations. There are 4 types of asymptotic notations we see in our next class. Okay, now coming to space complexity. See, coming to space complexity, it is the amount of space that an algorithm is required for its complete execution is called as space complexity. See, as it is as a time complexity, in this we have 3 types of space complexities. One is best case, worst case, and average case. See, here you can elaborate your answer by writing these definitions, writing these definitions where you have already written here, right? So here an algorithm takes minimum amount of time now here. So in the place of time you substitute with space. This definition will be elaborated much. Okay, now coming to the how we calculate the space complexity. This is a formula of space complexity to be calculated, right? Now coming to S of p in the sense space complexity. C is nothing but it is a constant or an individual part or independent part. This C is constant, right? This constant was independent from both the variables. Now it is this SP is nothing but space complexity, or it is a variable. It is a variable which is need to change, or it is dependent upon the other constants or other variables. So coming to this constant, it is a C is nothing but constant. It is independent. It is independent from other variables. So let us see an example, then you can easily understand about this space complexity. Coming to here, algorithm for sum of two numbers. Here we need to take an algorithm for sum of two numbers. See, here I opened int is nothing but it is a function int sum. A and b are two parameters and return a plus b. Now here SP is nothing but a space complexity which is equals to C is nothing but the number of constants, and SP is nothing but a number of variables. See, here we have A is a constant value and B is a constant value which should not be changed or which is not able to change, and there is no variables here. So don't confuse here. We have no variables. There is no variables, only we have constant. They are both A and B. So about about this variables you can understand in clear manner in next example, that is of array, uh, algorithm for an array. See, algorithm to find an array or a sort an array or just display an array. Now see here, sum is a function. I opened here x comma n are both are constant. See here, both x comma n are constant, and we need to have an independent variable. See here, the variable here, see, a and b are two variables. A and B are two variables which are not independent. They are independent from each other or independent from others. They need not to be changed. But here, I, coming to here, I is the variable which is used to change its value. See, by seeing the algorithm you can understand in clear manner. See, here we have total equals to 0 for I in range, I equals to 1, I less than I less than n, and I plus plus, right here, and total equals to total plus x of I. Here space complexity defines the number of constants or number of constants plus number of variables, number of independent constants plus number of dependent variables. See here, c is nothing but number of constants. We have x comma n. X comma n are two independent constants, and here now coming to sp is nothing but I. What is the range of I here? N, right? Range of I is n. Here n is nothing but, there is no, like here starting initial value of n is 1 and there is no end. It's up to n, right? See, if here n value is 5, the range of I is from 1 to 5. Then we can easily write here n value equals to 5 if n equals to 5. But there is no a particular end of the or a particular value which is given to n by its end. So we need to consider it as a n. Okay. Now 3. What is here? Here x comma n are to both constants, and total here. Total is also a constant which is initialized here. So here 2 plus 1 total 3. Here completely constants are 3, and there are n number of dependent variables. So this is all about space complexity of an algorithm. See, space complexity of an algorithm is 3 plus n. So this is all about complete basics of algorithm or introduction to an algorithm. See, I'm once again take screenshots or completely write the notes, which is all about algorithm and performance analysis. See, this is all about algorithm and performance analysis, time complexity, and best case time complexity, worst case time complexity, and this is all about average time complexity. And space complexity. So that's all in this video. Let us discuss about asymptotic notations in the next video. Don't forget to like, share and subscribe, and thank you for watching.